Okay, so here's another problem with the method of Lagrange multipliers. We wish to find the minimum and the maximum of the function xy on the ellipse x squared plus 3y squared is equal to 6. And we recall that if we have a constraint in two variables, meaning a function of two variables set to 0 that defines a curve, and we want to find the minimum or the maximum or both of the function that is usually known as the objective function on the curve g of xy equals 0, the objective function being f of xy, then this is done by finding critical points for that function on that curve using the system which is made up by the condition that the gradient of f is parallel to the gradient of g, and g is equal to 0. Again, these are critical points. Usually, there has to be some sort of condition or reasoning that ensures that a minimum or maximum exists. In our case, of course, the ellipse is a compact set, which means that a minimum and a maximum are guaranteed to exist. So let's get started here. We begin by defining a function that describes the constraint that gives us a level curve of it, the actual constraint. So we define g of xy to be equal to x squared plus 3y squared minus 6. And then we write down our system. What is our gradient for f? The gradient for f is yx, right? Y being the partial derivative of xy with respect to x, and x being the partial derivative of xy with respect to y. And that should be equal to lambda times the gradient of g, which is 2x and 6y. And then we want to require that x squared plus 3y squared is equal to 6. Again, let's write this in a more tangible form. So let's write this as y is equal to 2 lambda x, and x is equal to 6 lambda y, and x squared plus 3y squared is equal to 6. Now here we can make another, we're in a situation where there's a pretty straightforward observation that if x is 0, then that implies that y is 0, which is impossible, because 0 and x 0 and y 0 do not fit the constraint. Then if y is 0, then again x is 0, and that's also impossible. And same thing if lambda is 0. If lambda is 0, because of both the first and the second equation, we get x is 0 and y is 0, which is also impossible. So what this means is that x has to be different from 0, y has to be different from 0, and lambda has to be different from 0. And the reason we're making this observation is because we want to divide the two equations. And we have to make sure that the denominators that we get are non-zero. So when we do so, the lambdas cancel. We have an easy numerical cancellation. And if we cross multiply, we get 3y squared is equal to x squared. So now we can replace x squared with its equal in the constraint. So that will give us 3y squared plus 3y squared is equal to 6, which means that 6y squared is equal to 6, which means that y squared is equal to 1. and y is equal to plus or minus 1. So if y is equal to 1, then by going back into the constraint, we get that x squared is equal to 3. And this implies that x is equal to plus or minus square root of 3. That yields 2 points. It yields the point square root of 3, 1 and negative square root of 3, 1. If y is equal to negative 1, we have exactly the same thing. So x squared is equal to 3. Again, we go back to the constraint. Let's make sure that everybody understands this. We go back to the constraint and we plug in y equals 3, which gives us x squared plus 3 is equal to 6, which simplifies to x squared equals 3. So again, we get x is equal to plus or minus square root of 3. That gives 2 more points. And we get a total of 4 critical points. And now, since we know that our minimum and maximum are guaranteed to exist, and these are the only possible places where this can happen, we can evaluate our objective function on those 4 points. And what we're going to get is square root of 3, negative square root of 3 here, negative square root of 3, and square root of 3. Remember that xy is simply the product of x and y. This means that this is a point of maximum, this is also a point of maximum, this is point of minimum, and this is a point of minimum. We found both the maximum and minimum values for f of xy and also where they occur. And that's all. Thanks for watching.